This is John. He desperately needs a small loan to cover for a medical emergency. He applies for one on his bank's website. The bank uses AI to decide whether an application should be approved. Now, the AI detects that John has a decent credit card history. However, it also notices that he often shops at discount stores. Because of its training data, the AI decides that people who do that are likely to default on their loans. Hence, the AI, without understanding John's situation fully, rejects his application. John, now unable to pay his medical bills, doesn't even know why. This is what researchers and engineers call the black box. It's like going up to your teacher and asking them a maths question. They're able to give you an answer, but you don't know how they arrived at that answer. Similarly, in AI, we know the input or the maths question and the output, the answer to that maths question, but the internal processes remain unknown. In case you're wondering, no, it's not as simple as asking it to explain its working or how it got an answer. It goes deeper than that. It may be able to show you how it solved a math problem step by step, but our concern here is how did it form those internal concepts in the first place? What if its thinking works for this particular context but not others, and we don't even know it? And this black box problem exists in the AI tools that you and I use on a daily basis, like ChatGPT. We still don't know how AI is able to make these relations or reach a particular conclusion. But most big tech companies are focused on making it work rather than finding out why it works, which may seem okay right now because generative AI is still quite new. But in the long term, this ignorance could prove dangerous. Okay, look, the creation of generative AI is so novel that it will eventually be used in many major areas like banking, politics, business decision making, medicine, security, and the list goes on and on. So it's really important that before AI becomes so widespread, we understand it thoroughly. To give you an example, let's start with something small. Tesla robotaxis. You might have heard about Elon Musk's Cybercab, which is a fully autonomous vehicle with no steering wheel. You input a destination and the car takes you there. Now, I know how that sounds, and it raises a lot of concerns as well. Say if, touch wood, the car gets into an accident with a bicycle. Who is to blame? The cyclist, the passengers, the owner of the car, the regulators, Tesla, Elon Musk? In fact, such accidents have happened before. Tesla's self-driving technology, as the engineers say, is a black box. In the future, AI may be used to detect criminal threats or be used in the judiciary system. And since AI is trained on data provided by humans, there is a high chance that it carries the same biases that humans carry. After all, AI is about pattern recognition. In this case, the black box is preventing us from analyzing how the AI is flagging threats. And when police officers blindly trust this model, it could lead to higher injustice in society. So I hope you can see how big this problem is. But the question still remains, if we're the ones who made it, why can't we understand it? So here's a more technical explanation. The term artificial intelligence, first of all, isn't entirely accurate. We're talking about a subset of artificial intelligence called deep learning. Here's what a deep learning model looks like. It has an input layer where all the input data goes, followed by the hidden layers where the analysis happens, and the output layer which gives you the result or the answer. Our problem, the black box, lies in this hidden layer where the learning actually happens. The structure of deep learning is highly inspired by how our own brains work through neurons. In our brains, the neuron contains dendrites to receive signals, soma that processes the signal, and axons that pass the signal to other neurons. In a deep learning model, each neuron is meant for a specific task. Neurons that work on the same type of input are called a layer. And there are many layers that exist in a black box, all of them learning and forming billions of connections to analyze and predict things better. Apart from neurons, deep learning models also have this thing called weights and bias. Suppose you have layer 1 with 3 neurons and layer 2 with 2 neurons. Total connections would be 6. Now, each of these connections contain a weight that controls how each input affects the neuron's output. So since we have 6 connections here, that directly means 6 weights. Now, suppose that each neuron in layer 2 also has a bias. So that makes 2 biases. So 6 weights plus 2 biases means 8 parameters. And as I've mentioned in my videos before, parameters roughly equate to how well a model can solve problems. Now, here's the problem. You can tell just by looking at this image that the data is processed in a non-linear manner. It doesn't follow a straight line. It's not like a bus going from one bus stop to another in order. The information is being divided, distributed, and processed simultaneously through billions of connections. That's why it's so difficult to trace what's happening to the data and how the model is able to create patterns, logic, and solve problems. This is what we call a black box. So we have a problem in front of us. Question is, what's being done to open this black box? One approach being taken right now is making AI models transparent and understandable to humans. This field of research is called Explainable AI, or XAI for short. The aim of this research is to reveal what's going on under the hood, to help users, developers, and regulators understand how a model makes decisions. So going back to the example at the beginning of the video, if the AI were to reject John's application but also give a reason as to why it was rejected and state the concerns or the criteria that were met, the bank staff will be able to get a fuller picture and then decide how they can proceed from there on. Chances are they declare that the AI was wrong and approve John's loan. Increased transparency will lead to higher trust. Right now, Google, IBM, Microsoft, and ethics groups are working on researching their own XAI models. The end goal, like I said, is transparency, accountability, safety, and fairness. Another approach is visualization, creating a map of what's going on inside the model. The thing is, when deep learning models are processing data, they convert everything to numbers, and that doesn't mean much to humans. So through visualization, developers aim to decipher how the data flows in a model, how the neurons light up, and how it transforms through each layer. The limitation of this is, again, it shows what the model is doing, but not why it's doing it. So naturally, the next alternative is to build a model from the ground up. A model based on decision trees, linear regression, and rule-based systems. These models are better when the stakes are high, like in medicine or legal settings. If everything is in the format of if-else statements, it becomes a lot easier to trace and reduce bias. But again, the problem with these kind of models is they can't work with large data sets or complex data. So there's no clear solution to this problem as of yet. Now, you're probably wondering, okay, I understand what this black box problem is and what's being done to solve this, but why does it concern me? Well, believe it or not, but AI will directly or indirectly affect you because it will become the go-to tool for making decisions. Whether you're getting a loan, applying for a job, a visa, seeking healthcare, or even driving a car. So it's important that we know how these decisions are made so that your life, my life, and of every person on this planet isn't left up to statistics. People are getting unfair treatment because of black boxes. Cars on the road are taking lives because of black boxes. This problem affects us every day. We can't let AI understand us more than we can understand it. If we don't understand how a machine thinks, who's really in control here?